Alright, so we're going to start combinations and compositions of functions. And so hopefully this is something that you've done before in Algebra 2, and this is just kind of a refresher. And so we're going to look at numeric combinations and algebraic combinations, and the same with compositions. So these are the 4 ways you can combine functions, with addition, subtraction, multiplication, or division. These are also the 2 different ways that you can see them ask you to do those 4 things. So f plus g of x is the same as f of x plus g of x. Same goes for subtraction. The only thing you need to make sure of is, since you're subtracting g, you need to distribute this negative. Multiplication and division. And the way that I think of these types of combinations, I think of these as dates between 2 people. And f is the name of this function, g is the name of this function, so I say it's just short for Fred and Grace. And so these are all dates. These combinations are all dates that Fred and Grace go on. And so they go on all these dates until they finally get married. And so compositions are when they get married, because Grace has a ring, and so it's fog. They become one. And so when you do a composition is when you plug one function into another. So this is their like wedding night. And so I just think of it that way. It helps me to remember what I do with f and g whenever I've got fog or goth. And so these are the 2 notations that you could see when they're asking you to do a composition also. F circle g, or you could see f of g. Okay, same thing for g of f. Alright, so let's look at a couple of these examples. So these are just numeric combinations and compositions right here. And so all I've got instead of x in these small parentheses are numbers. And so I'm going to show you how I would work those to make it easier. So this is g plus f. So I'm going to write down g. So this is 4x plus 5. That's g. Plus f is x squared minus 3. And so in for those x's, I'm going to plug this number that they gave me right here. So this will be 4 times 2 plus 5 plus 2 squared minus 3. And so if I plug all that in, that'll be 8 plus 5, which is 13, plus 2 squared is 4. That will be 17. And then 17 minus 3 will be 14. Alright, I'm going to do the same thing with part B. This is f minus g. So f is x squared minus 3. Minus, I'm going to put this in parentheses because I want to make sure this negative goes to everything in g. And so g is 4x minus 5. Now, everywhere I see an x, I'm going to put a 3 this time. So this is going to be, I'm just going to write over this, 3 squared minus 4 times 3 minus 5. And then you can either just plug that into the calculator or work it out in your head. When you work it out, this is going to end up being 9 minus 3 minus 4 times 3 is 12. Oh, and this should be a plus 5 right here. Sorry about that. So 12 plus 5 would be 17. And so then I would have a 6 minus 17, which would give me negative 11. And so negative 11 is my answer for part B. Now, part C, this is a composition. And so what this notation means is that f is my outside function, and g is the one that I'm plugging into f. So when I do these, I look at my outside function, which is x squared minus 3. And everywhere there's an x, I put a big parentheses. So big parentheses squared minus 3. If I put my x there, I would just have x squared minus 3. So here's my outside function. My inside function is g, and so that is 4x plus 5. Now, this is telling me to put 5 where that x is. So I'm going to have 4 times 5 plus 5. That's just going to be 25 squared minus 3. So that'd be 625 minus 3, and that's just going to give me 622. Alright, I'm going to mark that one out because it's the same. And then part E, this one has a couple of different combinations and compositions going on within there. So f of negative 2, I'm going to do that first. This is just telling me to plug negative 2 in for x to the function f. So I'm going to have negative 2 squared minus 3 plus, this is telling me that g is my outside function. And so g is my outside function is 4x plus 5. So I'm going to put 4 big parentheses plus 5. And in this big parentheses is going to go f. So I would have x squared minus 3. And then for that x, this is telling me to put 2 there. And so then I'm just going to simplify. This is going to be 4 minus 3 plus 4 times 4 squared minus 3 is just going to be 1 plus 5. And then I just work this out. So 4 minus 3 is 1, plus 4 times 1 is 4, plus 5. So this is just going to be like a 5 plus 5, which is 10. And so my answer here is 10 for that combination. Alright, let's look at some algebraic ways that we can combine these with these two functions. So f plus g, this is just telling me to take x squared minus 3 and add 4x plus 5. And I'm just going to combine like terms. So I'm going to combine my numbers basically. And so when I do that, that's going to give me x squared plus 4x plus 2. And that would be my combination. Now when we subtract these two, this is just going to be me taking x squared minus 3 and subtracting, I need to put it in parentheses, 4x plus 5. And so when I distribute that negative, this is going to be x squared minus 3 minus 4x minus 5. So I get x squared minus 4x, and then these combine to be a minus 8. Alright, last one, f times g. And so this is just going to be me taking x squared minus 3 and multiplying it by 4x plus 5. So x squared minus 3 times 4x plus 5. And the way that I'm going to have to multiply these is by distributing. And so when I distribute these things out, the first two terms are going to give me 4x to the third. Outside terms are going to give me plus 5x squared. Inside terms are going to give me negative 12x, and the last terms are going to give me a negative 15. And then there's nothing else that I can combine there. Every term is different. Okay, I can't combine, so then that's my final answer. Alright, let's look at a couple of different types of functions with these examples. So this is telling me to do f of 6 plus g of 6. So this is going to be the square root of 6 plus 3 plus the square root of 6 minus 2. And that's just going to be the square root of 9, and this is going to be plus the square root of 4. So square root of 9 is 3, plus square root of 4 is 2, so I get 5. Alright, f of g of 38. So what this is telling me to do is, f is my outside function, so I'm going to say square root of, big parentheses, plus 3. Inside the big parentheses is going to go my square root of x minus 2, and in for that x is going to go 38. So this is going to be the square root of 38 minus 2 is 36, and the square root of that is just 6. So square root of 6 plus 3 is just the square root of 9, which again is just 3. Alright, f of 21 times g of 10. So f is square root of x plus 3. So I'm going to say square root of 21 plus 3. And then I'm going to multiply that by the square root of 10 minus 2. And so these are not going to work out as nice and pretty as these last two, but I'll show you how I want you to work it. So 21 plus 3 is 24. And so we've got the square root of 24 times the square root of 8. And so before I multiply these, I'm going to go ahead and, well, there's a couple of different ways you can do it. Whenever you have radicals that are being multiplied, it's okay for you to multiply the numbers underneath there. And so if I multiply 8 times 24, that'll give me the square root of 192, and then you can reduce that and simplify. But what I'm going to do is I'm going to go ahead and reduce these and simplify them on their own. And I'm going to break them up into a number times a number that's a perfect square. So a perfect square are numbers like 4, 9, 36, 16, those kinds of numbers, okay? And so a perfect square that would go into 24 would be 4, and then I would have to multiply that by 6. So from the 4, I can pull out a 2, and this should be something that you did a long time ago. So I would get 2 square root of 6 times, this is going to be broken up into 2 times 4. From the 4, I can bring out a 2, and I'll have a 2 left under my radical. And then I think it's easier to work with these numbers rather than working with bigger numbers if we were to have multiplied first. And so then what you do to multiply is multiply the outside, so that's not 2. That is 2 times 2, which is 4, square root of 6 times 2, which is 12. And then we're going to see if we can reduce again. Is there a perfect square that will go into 12? Yes, it is 4. And so from the 4, I can bring out a 2. And so 4 times 2 would be 8. And then I would have that square root of 3 left. So I would have 8 square root of 3 is my final answer. It can't be simplified anymore. Now, f divided by g of 8, this is just taking my f function, x plus 3, and dividing it by my g function, x minus 2. And I'm going to plug in 8 for those x's. So this is going to be 8 plus 3, which is square root 11. 8 minus 2 is square root 6. Neither one of these by themselves can be simplified. If they could, I would go ahead and simplify them. But since they cannot be, I'm going to go ahead and rationalize. That means get the square root out of the denominator, and we've done this before, especially when we worked with trig a lot. So this is going to be the square root of 66 over 6. And then there's no perfect square that will go into 66 evenly, so this is my final answer. Alright, so now we're going to combine these functions algebraically, and when we've got square roots, there's really not a lot we can do sometimes with our answers the way they're asking us to combine these. And so when I combine f of x, that's x plus 3, plus g of x, which is just square root of x minus 2, I can't add these together because the numbers, or what's under the radical, isn't the same. And so this is just my final answer for f of x plus g of x. Now for f of x times g of x, this is square root of x plus 3 times square root of x minus 2. The only thing that has to be the same in order for me to multiply the things under the radicals is the fact that this is a square root. So if one was a square root and one was a cube root, we couldn't multiply what's underneath there. But since these match, we can. And so that's just going to give me the square root of these things FOILed out. And so I'm just going to go ahead and FOIL those in my head. The first two terms give me x squared. Outsides are negative 2, insides are positive 3, so that's a positive x. And then 3 times negative 2 is negative 6. And so then this is my final answer, and I can't simplify that anymore. Now, I want you to try these and these right here. So I want you to pause the video right here and try to figure out these A, B, C, and D. And then when I press play again, or when you come back to it, I'll write the answers up and you can see if you got them correct. And then I want you to do the same thing, so pause the video right here and try these two things, so f of g and g of f with these two functions. This is exactly like the first example that we did, so I want you to try these right quick. So these first two should have been pretty easy. These were exactly like a couple of the examples that we did before. And so these are your answers for A and B, so 206 and 790. Now, you may have struggled with C and D. That's because those are just a little bit different than what we did before, because you've got three things here. So I want to show you the easiest way to do this. First, I'm going to find f of 3. So f of 3 would just be 3 times 3 minus 4, and 3 times 3 minus 4 is going to be 9 minus 4, which is 5. So really this is gone, and I'm doing g of 5 now. And so then I'm going to go do g of 5. And so g of 5 is going to be 5 squared plus 6, so that's 25, plus 6, which is 31. And so really now this is gone, and what I'm doing is f of 31. And so f of 31 is just going to be 3 times 31 minus 4. Let me scroll up. So 3 times 31 minus 4, my parentheses should have gone before that minus 4. So I just plug 31 in for here, in for this f. So 3 times 31 minus 4 is going to be 89. And so this whole thing should just be 89. So 89 is the answer to this, and I think that's easiest to do it like that. So we're going to do this one the same way. G of 4. This is telling me to plug 4 in for G. So if I plug 4 in for G, that'd be 4 squared, which is 16. And so 16 plus 6 is just going to be 22. And so really this is just 22 here. And so now I'm doing G of 22. So I'm plugging it back in here. So I'm going to do 22 squared plus 6. And if you type that in, 22 squared plus 6 is just 490. So really,